let's get started. Group 3.
Yeah, thanks. Okay, so hi, we're going to present ISEAL squared, which is identifying spam email with seal. So I suppose everyone here is familiar with the concept of emails. And the thing is that the commercial email vendors such as Gmail, Outlook, Yahoo, they store all your emails in plain text on their servers. And there are new services for end-to-end encrypted email applications because obviously we don't want anyone to read our emails other than ourselves. So we do, for example, have Proton Mail and other plugins that you can install on your web browser to have end-to-end encryption on your email. And this is obviously very nice because if it's encrypted, then it cannot be decrypted or read or shared with third parties without you decrypting it. But there is a small catch, because when we have encrypted end-to-end emails, like I said, no one but you can read your emails. So then the question becomes, how can we identify spam or phishing emails? And the current solutions that, for example, Proton Mail uses is that you have blacklists and whitelists, and there's also local filtering. So it searches through whether or not it says, you've won the lottery, congratulations, and it says, this is probably spam, probably. But this doesn't really comply with the spam filter, because the spam filters that are used on, for example, Gmail or Outlook, is that they're shifted through a machine learning model, and then it's classified as spam or ham. So in a bit more detail, you have your email, and then there is a feature extraction based on this email, and these features include, for example, number of capitalized words, the number of words containing both letters and numbers, etc., etc. And then this feature vector is then implemented into the machine learning model. And this is based on, for example, logistic regression, but there are also other models being used. And then once the feature vector has been shifted through the model, then it's classified as spam or ham. And this is a fairly straightforward operation. So one question is, okay, so if we have encrypted emails, then why can't we just do this ourselves if it's so easy? And there is a problem with this, because if everyone sort of starts building their own spam filter for their own personal email, then it's not going to be very accurate, because you have a very small data set for training your spam filter. So the machine learning algorithm is not going to be very precise compared to the massive amounts of machine learning algorithms that other vendors have, because they have much more emails to train the models on. So this is not a very good solution. Then you have another solution, which is you have this large corpora of spam emails available online that you could potentially use to train your own spam filter machine learning model on. But the problem is that this turns into a one-class classification, meaning that you train your model on just one type of data when you actually wanted to distinguish between two. So this solution, even though it solves the problem of having a small data set, has another, and it's going to result in a lower accurate algorithm or model, just because it doesn't do as well as if you have a large data set with both spam and ham emails being represented. So we're presenting a solution to this that's also complementary to the blacklisting and whitelisting already implemented.
So as Martha said, there is no efficient solution in order to check if an encrypted email is a spam or not. But we think that we can provide a solution in the current settings, so relying on the current email infrastructure. So for exchanging email end-to-end encrypted emails, we rely on existing solutions. And then when the user receives an email, he first decrypts this email and then creates a vector of features that describes the email. Then this vector is encrypted under homomorphic encryption and sent to the service provider, which can then rely on the model that he already has, that he trained over multiple years on clear text email, he can use this model in order to do the classification of the email based on homomorphic encryption. And so he obtained a classification which is still encrypted, which says if the mail is a spam or not. And then this encrypted classification is sent back to the client, which can decrypt and then automatically knows if the email is a spam or not. In this case, he obtains the classification without disclosing the content of his email to the service provider. However, we can notice that a problem can arise with this solution because the service providers cannot train anymore their model if they cannot see the content of the emails. So if everyone starts to encrypt their email, then they cannot update the model, and the model will lose its accuracy over time. And we then have to propose another solution that will also enable to train the model using this encrypted data. And so in the second part of our solution, we rely on the same scenario as before. So the user receives an email, it decrypts it, then creates the vector with the features of the email, and this time it encrypts it under the public key of the service provider. All the users are doing this operation, and then they send the encrypted vector describing their emails to the service provider, which can then use this encrypted information in order to update and to train their own model. Then this model is in plain text at the service provider, and in order to obtain classification, we have two solutions. Either the user rely on the first solution that we presented, so they send their encrypted features vector to the service provider, which answered with an encrypted classification, or the model can be the updated model can be directly shared with the users, which will use this model in order to locally classify their emails as spam or not. And so in this case, we notice that all the users encrypt their information under the public key of the service provider, and they have to trust that the service provider won't simply decrypt this information in order to just read the content of all the emails. And in order to not have to trust this single entity, we, as it was presented before, we rely on a distribution of the trust by having multiple service providers which will combine their public keys in order to create a collective public key under which the content of the emails can be encrypted, and the training of the model will be performed encrypted under this collective key. And then when the model is updated and has to be sent to the users, it can be decrypted by doing a collective decryption in which all the service provider collaborate. So in this case, the confidentiality of the emails is preserved as long as at least one of the service provider doesn't collude with the others in order to decrypt all the emails. So in terms of performance, we are relying on logistic regression. So logistic regression, in order to perform a classification, is very lightweight. It's only one plain text ciphertext multiplication, then some rotation, and then the activation function has to be performed, requires multiple multiplication of ciphertext, but this depends, the complexity of this operation depends on the degree of the approximation of the activation function. So for classification, it can be efficient, while for the training of the model, as it requires multiple iterations and matrix multiplication, it can becomes much more heavier. However, there are some existing recent works that shown that a model can be trained on a fairly big data set under homomorphic encryption in a reasonable time. And some optimizations are possible. So we can, for example, update the model. We can wait more time between each update of the model, so only do the update once a day or once a week or even more. We can also optimize the operation by batching more information in the vector. So, for example, a user would wait until he has many emails in order to encrypt all of them in one ciphertext and then send this to the server. And if we have the problem that the service provider receives too many emails to classify or to train his model from the users, then he can sample the data in order to train only on a part of the data set and then reduce the complexity of the training. So to conclude, we propose two solutions. One for the classification of the emails as spam or not, which can be directly plugged in existing infrastructure and which can be efficient. And we also propose a solution for the training of the model that is used for spam detection, for which there are more challenges than for the classification, but which can still be a possible solution. And in terms of future work, we foresee already one problem, which is how to have multiple providers that would agree in order to participate in this system, because we know that it's difficult to have big companies to collaborate together to offer one service. And also the efficiency of the solution will depend a lot on how we pack the data and how we set the parameters in order to perform the training of the model. And that's it.
Okay, so I have one question. So it seems like the privacy of these emails are protected by having multiple service provider and they are not including each other. And how do you enforce that? Are those service providers from the same company?
Yes, so no, the goal would have to have independent service provider that agree to collaborate on this task. And yeah, the user would have to trust at least one of these service provider.
And all these service provider works for your company?
So
They're working like for different companies. You can imagine that we can have like Google and Symantec or Yahoo or like 3 different companies. And we need like one of them to be like trusted. Also, the idea that we have about future work is we can also engage the clients as part of the key management. So imagine that we have like now composite keys that part of them will be stored like in the clients, and we'll change that in order to be like fair in terms of computation. But this requires like more study, of course, because
yeah, okay. Like just it sounds a little bit harder to deploy that because it involves a lot of independent company that does not belong to you.
we need at least 2. There will not many.
Sure. Yeah.
Yeah.
So, little comment. Of course, the training is quite difficult, right? But you know, maybe something that you could do is you could just give instead the user an option of sharing their data, and this way the service provider could get the training data. You know, one of the problems with the current phone apps and all kinds of email services that one uses is that you have no choice. There's no way not to share, right?
Exactly.
So maybe if you could get by default, maybe, or maybe not even by default, but you could get this functionality that you get the service, namely the spam filtering. But then, alternatively, or in addition, you could also choose to share or not to share to improve.
Yeah, but like, I can see like one problem here that if I'm using like, for example, Proton Mail, I'm doing that because I don't want to share my data, right? So I can motivate the clients to share their data, but in a creative form.
yeah, but it's true that, for example, the mails that are indeed spam, like there is no reason to protect the privacy of spam that we would receive. So these ones, for example, could be sent in clear to the service provider to train the model. Then on the other email, on the other encrypted emails, then yeah, the problem is, do you want to share emails that you received under encryption or not?
I have two questions. So first, what's the motivation, users' motivation to submit their encrypted email to the server to improve the quality of model?
Yes, to then have an accurate model in order to predict if it's spam or not.
Yeah, but for individuals, I mean, their field emails doesn't change much the model. So
we can also make it like more lightweight, since we cannot handle like big data. So we don't have like to send like all the data, but we can periodically send like some of our data. Like because so if we are planning to do like this, like to implement this, we'll use like some sampling in order to be able to train on a representative to train our models in a representative manner. So I don't believe that there is like any efficiency issue there. We can send like only one email per day, per week. If we have like millions of clients, then we will still have like good data.
okay, then what if a malicious client just submits a random string instead of honestly generated ciphertext?
So this is like a very good question, but I don't believe that we will have an answer here. So you are saying that right now the client can actually have a malicious client, that he can choose like the data that he's sharing with us in a way that he will change the classification for like some emails from ham to spam or the opposite.
I would still
We
want
need like some verification there that I'm not sure how we can achieve that.
So for some companies like Microsoft, for example, where our customers are mostly other organizations and companies, right? Well, not necessarily like individual users. You can imagine that
Companies.
if we deploy to some, say, whatever Adobe, some solution.
Yeah. For
then,
B2B applications.
then they certainly wouldn't necessarily want to share anything, but they would still want to get this spam filtering. So in these cases, the system could maybe be trained on data coming from totally different sources. Right? I'm just like,
Yeah,
I'm just not convinced that...
we can definitely do that. So, and this is like something, what we are proposing here is that if we want to further optimize the accuracy of our model, we can try to do some complementary things. We can use like all the baseline solutions that we said, but we can use like different data sets. You can use like one class classification. But like at the end, so if we can at some point all are using like encrypted email applications, then all this data will become stale. So we'll need, there will be a need for like fresh data.
Of course.
So in that case, we have like, we're proposing this solution.
Yeah, but I still think that maybe you're making it very difficult by tying these together so close.
Great, thank you.